So, now we go for that lattice formulation of linear prediction. So, what is there? So, as I discussing that computation of matrix of correlation value or autocorrelation, what is the covariance or correlation does not matter. So, that require an complexity and efficient solution set of linear equation, that means an iterative methods, that is the requirement. So, but can I combine these two steps in one step? So, can I combine this step to one step? So, that method is called lattice formulation method. Let us go for that. What is that? Let us say, so when I say the prediction, let us say I have a sample. So, let us say I can say this is a signal which is many samples are there, many samples are there. So, this is my Sm sample, mth number of sample. So, if I say I want to I sample used to predict Sm sample. So, I want to predict this sample from previous ith sample. What is the meaning? Let us give an example. Suppose I have a signal x of n 1, 2, 3. Let us say I want to predict 3 based on previous 2 sample. So, here also I am predicting Sm based on the previous ith sample. So, what is the Sm minus 1, Sm minus 2, Sm minus 3, ultimately Sm minus I, previous ith sample. So, when I predict that way, that is called forward prediction. So, I can say that I am predicting 3 from previous 2 sample. Also, I can say I can predict 1 from that past, I can say that from these 2 and 3. So, prediction can go this way. Once it goes from 1, 2, 3, that is called forward prediction. This way. I can predict next sample, I can predict next sample. So, this is forward prediction. I can predict the backward also, I can predict 1 from 2 and 3, because xn is known. So, once the xn is known, I can predict both way. So, when I predict this way, that suppose I want to predict Sm I minus 1 sample from the previous, or I can say this side ith sample. Understand or not? So, I am predicting this sample from previous this sample, or I can predict this sample from previous this sample. So, when I predict Sm from previous ith sample, that is forward prediction. When I predict this side, this is called backward prediction. So, prediction can be forward, prediction can be backward. I can predict 3 from 1 and 2, I can predict 1 from 2 and 3. When I am predicting 3 from 1 and 2, it is forward prediction. When I am predicting 1 from 2 and 3, it is backward prediction. So, there is a forward prediction and backward prediction. Okay, you understand that part. Now, I come to that. What is the equation of the forward prediction and what is the equation for backward prediction? So, what is my prediction filter? This one. So, if I say ith order prediction error filter, so this is nothing but a prediction error filter, Sn minus previous sample, this is the previous sample sum. So, let us say ith order prediction error filter. So, Aij is equal to 1 minus k equal to 1. So, I can say ith iterative. So, this I represent the iteration and this I represent the order. As I said that suppose there is a sample. So, when I am predicting this sample from previous 14th 0 sample, the prediction error is maximum. So, first iteration I am predicting this sample, second iteration this one, third iteration this one, fourth iteration this one. So, once I go with the iteration, that error will be minimized. Okay or not? So, let us say ith iteration process is this one. So, what is the prediction error? EIM is equal to SM signal minus predicted signal. So, SM, this one is my predicted sample. So, in Z transform, I can say EIZ is nothing but a AIZ multiplied by SZ. SZ is the input signal. Now, what is backward prediction? I am predicting M. So, what I am predicting in forward? In forward prediction, I am predicting SM. In backward prediction, I am predicting S of M minus I. If the ith order prediction is used. So, I am predicting this sample, forward prediction I am predicting this sample. So, this minus estimated sample. So, backward prediction similarly this is my signal minus estimated signal. SMI minus, so that one plus 1 plus 2 plus 3, so that is why plus k. If you see, this is SM minus I, this is SM minus I plus 1. If I representing by S of, so suppose this is third, so I am predicting 1, so this is nothing but a first sample, so I can say the 2 minus, so this one is next part on this, so 1 will be added to this, so that is why this is added, k is added. Now, if I take the Z transform, so this will be Bz, this will be Z to the power minus 1 multiplied by Sz M minus I minus k equal to 1 to I alpha k I Z I, so Z minus I Z plus k into Sz. Now, if you see, this is k equal to 1 to I. So, I can say that Z to the power minus I is independent of this sum. So, Z to the power minus I is taken out, Sz is taken out. So, this is 1 minus this one. Now, if you see, this one and this one is almost same, only difference is that the here Z is Z to the power minus k, here it is Z to the power plus k. So, I can say instead of Az, this can be A Z to the power minus 1. So, I can say Bz is nothing but a Z to the power minus I multiplied by Sz into A Z to the power minus 1. So, Ez is equal to Aiz Sz. So, it is Aiz Z to the power minus 1 Sz. So, this portion except this error filter is Z to the power plus 1 is Z to the power minus 1 and multiply by Z to the power minus I. So, now if I say that I want to write down this one, how can I write down Aiz in term of previous error? So, what he said that Levinson said that it is recursion is possible. What recursion is possible? I can say that Aiz can be predicted from Ai minus 1z. So, I want to write down that part. How can I include recursion, Levinson recursion, so that I can calculate Aiz from the previous value. So, I know Aiz is this one. Now, I know alpha ki, this is the Levinson recursion equation. Alpha ji is equal to previous iteration result minus ki, the Parker coefficient, and alpha previous iteration. So, I just put this one instead of j, I said k and I minus 1 will be there. So, I can say alpha ki ith order, that means ith iteration can be written as I minus 1 iteration. K instead of j I am k writing k. Now, if you see this is k equal to 1 to I. Let us say I said this summation will be I minus 1. So, k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k minus k I minus, so this is nothing but a alpha, that will be k I, sorry, k I is missing in here. So, k I into alpha I minus k z to the power minus k multiply, and what I am written, one term I have not written. So, this is my last term. So, this is nothing but a k I. So, in the second stage I writing this one as a k I, and this one if you see minus, so I can say 1 minus this one and minus minus plus k I into k equal to 1 to I minus 1 this one minus k I into z I, z to the power minus I. Now, I can say this is one term, and if I say k I, because summation is not independent of I, so k I is this side, k equal to I minus 1 to I, this one I can put. Okay. So, I put k dash equal to I minus k. I minus k is equal to k dash. Okay. So, when k equal to 1, it is nothing but I minus 1. When k equal to I minus 1, it is nothing but I. So, I can write down this one. Now, I can see this one is nothing but a ai minus 1 z, because ai z is equal to this one. So, ai minus 1 z is nothing but alpha k I minus 1. So, ai minus z, and if I say k I and z to the power minus 1 is outside, then it is become 1 minus this one into. Now, if you see, this is z to the power plus k. So, if I make z is minus k, so it is nothing but a I minus 1 z to the power minus 1. So, I can say that a I z is nothing but a I minus 1 z minus k I into z to the power minus I, a I minus 1 z to the power minus 1. Now, if this is my error, prediction error filter, so the prediction error is nothing but a multiply by the signal. I put this Sz. So, if you see a I minus 1 z Sz, so I can say it is nothing but a E I minus 1 z, and a I minus 1 z to the power z minus 1 Sz, which is nothing but a Bz. Bz is this one only in this form. So, I can say I write down the Bz. But one thing this is z I minus 1. So, I require z to the power minus 1, because I required z I minus 1 previous one. So, 1 minus z to the minus n will be written, so that it can be I minus 1 plus 1, or I can say if I is common, j I minus 1. So, that is why 1 z to the power minus 1 will be remain and k I will be remain, and this b I minus z. Now, from this equation I can say that E I m in time domain. So, this is in z domain, I minus 1 E I minus 1 m minus k I into b I minus 1 m minus 1. Understand not? Similarly, if I put Biz, so z to the power minus 1 Sz, a z to the power this one, again I can say that this is nothing but a this one. So, which is nothing but a Bim is equal to b I minus 1 m minus 1 k I into E I minus 1. So, now say that this is my equation forward prediction error, this is my backward prediction error. Now, what? So, I can say that ith iteration is nothing but a I minus 1 iteration. So, if I say 0th iteration, so I equal to 0, E0 m is nothing but a Sn. There is no iteration. So, error is nothing but a signal itself. itself is the error. So, it is nothing but ASM. Similarly, B0M is nothing but ASM. So, I can say that when I do the signal flow diagram, I can say this is my speech signal or a signal SM. So, I can say this is nothing but a E0M, this is nothing but a this is nothing but a B0M, this is nothing but a E0M. So, this is 0th order prediction, 0th iteration. So, which is nothing but a signal itself. Then what is E1M? So, I know this one, this equation E1M is nothing but a E0M will be there minus K. So, I equal to 1 minus K1 equal to B0. So, E0M minus K1 into B0 M minus 1. So, this is B0 M. So, what is, how do I synthesis B0 M minus 1? I put a z to the power minus 1 delay. So, this is nothing but a B0 M minus 1. So, this will be added up with this one with a minus K1 coefficient. What is K? K is nothing but a partial reflection coefficient or PARCOR, a partial correlation coefficient. If it is on go for tube model, it is called partial reflection coefficient. So, it is act against partial reflection coefficient, PARCOR, partial correlation coefficient. Okay. Now, what is B1M? B1M is equal to B0 M minus 1 minus K1 E0M. So, I know that B0, so this is my B1M. So, B1M will be this one will be multiplied minus K1 and added up with this one, I get B1M. Now, when I say E2M is nothing but a E1M minus K2 into B1 M minus 1. So, B1 M I know. So, that will be delayed by one sample, B1 M minus 1 I get, and this is my E2 M. E2 M is this signal multiplied by this signal with a minus K1, K2, and B2M is nothing but a, this will be multiplied by minus K2. So, that way I can say this is nothing but a, let us say, pth order. So, EPM I will get and I will get BPM. So, this side I will get BPM, this side I will get EPM. So, what is BPM and EPM? BPM is nothing but a final error. So, final error is nothing but a EM, BPM or APM, whatever I can say, that is nothing but a final error. So, I can get the final error. So, what I said, I have a filter, if I apply SM and this is I implemented in here, I will get EM. So, what I have to know? I have to know K1, K2, Kp. So, let us say all K value I know. Once I know all K value, I can implement that signal flow diagram in a computer, and if I apply SM, I can calculate EM. So, that is called lattice implementation, because if you see one block, this block, there is another block, there will be another block. So, each block is simple, only K1. So, I can say the one for loop, only if you say the for loop is repeated for K1, K2, K3, K4, Kp. So, P stage will be there for pth order prediction. So, I can implement AZ immediately if I know K1, K2, Kp. So, when I say synthesis, let us say I want to implement a synthesizer, that means which is nothing but a 1 by Az. So, here I apply Sm, I get Em. Now, if I see the signal flow is reverse, so I apply Em, I should get back my Sm. But signal flow will be in reverse direction. So, how do I do that? How do I do the reverse direction signal flow? This is the diagram which I already drawn. So, I want to draw the reverse direction signal flow. Let us say I just delete this one and again I want to draw it. So, what I said, if I apply Sm input, I get Em. Now, my target is I know Em, I know EPM, I know BPM. I have to get back the signal Sm. So, that means I know EPM, I know BPM. So, all our EPM is equal to BPM at the final stage. So, let us say I know Em, so which is nothing but a EPM, here is nothing but a BPM. Now, what I want to know? So, what is known? I know EPM. What I want to calculate? EP minus 1 M. So, I can say that EPM is equal to EP minus 1 M minus Kp into Bp minus 1 M minus 1. Now, what I want? I want EPM. So, I said the EPM, EP minus 1 M is nothing but a EPM plus Kp into Bp minus 1 M minus 1. So, let us say this one is my, this point is my EP minus 1 M, this point. So, how do I know? EP minus 1 is nothing but a EPM, so this signal directly goes to here and I require Kp multiplied by Bp minus 1. So, let us say this one is B, this one is B, Bp minus 1, M minus 1. Let us say this one. So, this one will be multiplied by plus Kp and I will get EP minus 1 M. So, how do I get Bp minus 1 M? So, from this equation, I know Bpm is equal to Bp minus 1 M, M minus 1 minus Kp into EP minus 1 into M. Now, I say Bpm P minus 1 M is equal to M minus 1 is equal to Bpm plus Kp into EP minus 1 M. So, if I know EP minus 1 M, if I know Bp, so this one Bpm, I know Bpm. So, if I want to know that Bp minus 1, so I have to delete the signal. So, what is required? So, what I can say that okay, let us say the Bpm I want to generate. Let us say I want to generate Bpm. Instead of Bpm, I am generating Bpm. Okay. So, what I will do? I will draw it fresh. What I know, let us say I know EP. EM is no, EPM is no, EPM is known, and this one is let us say BPM. So, this one if it is delayed by z to the power minus 1, then this one this is BPM, this one is nothing but a, so this is delayed by z to the power minus 1. So, this one is nothing but a one sample delay. Okay. So, this is Bp minus 1 M delayed by one sample. So, this point I get Bp minus 1m. This point, this is Bpm. So let's say this is Bp minus 1m. So I know Epm, let's say this one is my Ep minus 1m. So Ep minus 1m is nothing but this sample multiplied by this will be multiplied by Kp. Understand or not? So this point is my Epm and this point is my Ep minus 1m. So this point is Bp minus 1m minus 1 multiplied by plus. So I know that Ep minus 1m is equal to Epm plus Kp into Bp minus 1 m minus 1. So I know this is Bp minus 1 m minus 1, this will be multiplied with Kp and I get Epm. Now what is Bpm? Is nothing but a Bp minus 1. So this is Bp minus 1, this will go here minus, so this is nothing but this is Ep minus 1. So I can say this will go here multiply minus Kp. So this is nothing but a Bpm. Understand? So ultimate signal flow diagram will be what? This is Epm. So this is my plus Kp. So I get Ep minus 1m. After this point, it is Ep minus 1m. So from that, so just only is the signal diagram. So from here, if I take Ep minus 1, I am taking multiply minus Kp, I get Bpm in here. Understand? So if I apply Em in here, I get output Sm in here. Because I know E0 and V0 is same, so Sm, so this is backward and this is forward signal flow. So why I am implementing? I am implementing 1 by Az. First one I am implementing Az, now I am implementing 1 by Az. Understand? Again it also a lattice. 1 lattice. Understand? So now if I apply error signal, if I know K1, K2, Kp, so in the when I say the voice is transmitted, so I analyze, I said K1 to Kp, I extracted, I transmitted in the receiver side. From K1 to Kp, I can generate this filter and I can pass the Em. What is Em? Em is nothing but a Gotthold excitation in case of voice. So that is nothing but an impulse. So I can, if I pass an impulse, I can get back the speech signal again. Is it clear? So that is called lattice formulation. Now how do I get K1 value? Can I calculate the K1 value using autocorrelation? Yes, you can do that. But again I have to do autocorrelation and also I have to implement the filter. So synthesizer side is I know that I have to implement the filter only these methods. But in analyzer side, this is how can I can use it for analyzer. So how can I directly calculate K value from Bpm and Apm and how can I directly implement it? So how can I calculate directly this K1 to Kp value? One solution is that if I know K1 and Kp value, I can synthesize the signal Sm from the error signal. In ideal cases, error signal is 0. Error is minimized. Understand? So from the error signal, I can synthesize the signal. So I have to know K1, K2, K3, Kp. Now when I analyzing, when I this diagram, I am inputting the Sm signal, I can calculate the error signal if I know K1, Kp. So how do I extract the value of K1 and Kp? I can extract those values using autocorrelation, okay, no problem. I can extract those things. But can I directly compute that K1 and Kp value? So in the next class, I will describe how do I directly calculate K1 and Kp value, and I give an example. Let's say given signal, I can give you the example so that how it can be implemented in computer programming you should know. Okay? Thank you.